Okay, I'm unmuted, I think. 10, 9. Ready? Good afternoon, everybody. I hope you can all hear me. Welcome to Steel Times International's program of free webinars, which incidentally we've been running since the dark old days of the pandemic. Today we bring to you a webinar about Industry 4.0, a subject very close to our hearts, as it is very much focused on the steel factories of the future. And of course, it fits in perfectly with Steel Times International's premier convention and exhibition, the Future Steel Forum, which will take place next June in Stockholm in Sweden, which might one day be known as the spiritual home of green steelmaking, who knows. Today's webinar is sponsored by PSI Metals, and it features two speakers, one from PSI Metals and one from a company called Tavarit. PSI Metals is the leading supplier for production management solutions in the metals industry, combining SCM, APS, and MES to optimize production and logistics. It's a subsidiary of PSI Software SE, and the company has 50 years of experience in the sector of production management. Tavarit offers industry-specific artificial intelligence or AI solutions for metal manufacturing companies in order that they can achieve energy and resource efficient production with minimal waste. And of course, those words energy and resource efficiency lead me nicely on to say that next year's Future Steel Forum in Stockholm, Sweden, will have a strong focus not only on AI, but also energy and resource efficiency in steelmaking. So it's going to be quite a broad field. Now, just to give you the date for that, it's the 18th and 19th of June 2024. On the 17th of June, the day prior to the event, we're looking at having a plant tour at the Avako steel mill in Hofors in Sweden, which I've actually been to, so I can vouch for the fact that it'll be a great trip. So yes, look out for all the announcements on the Future Steel Forum. I'm sure that PSI Metals will be there as a speaker. I'm more than likely sure that Tavarit would be interested as well. So hopefully you'll be able to see the two companies live and in the flesh. But for now, let's carry on with the webinar. Today's speakers, in order of appearance, are Luc van Neeron, Innovation Manager, PSI Metals, and Managing Director, PSI Metals Belgium, and Vikas Goel. I hope I pronounced that correctly, Vikas. He's the VP of Operations at Tavarit GmbH. So without any further ado, I will introduce you to Luc van Neeron.
Okie-doke. Thank you, Matthew, for the nice introduction. Can somebody say that everything I'm hearable? Somebody can hear me?
Yes, we can hear you.
Okay, thank you. So yes, I'm very happy to be here today. My co-presenter Robert unfortunately couldn't make it, but I'm happy that we have 2 points of view today on artificial intelligence and Industry 4.0. We have more the traditional PSI Metals, like Matthew explained, the production management software company, and then we have Tavarit, and these are really specialized in AI models in the steel industry. So you have those different points of view, and I think that it could be very interesting for our audience today to have those different points of view. What I am going to talk about today, and the title is perhaps a little bit long, but what I want to talk about is, okay, if we want to introduce AI models into the steel industry or into the metals industry in general, we have to bridge a gap. And this is a very important step we have to make. We have to bring together the traditional production quality and production and planning and scheduling production experts. And of course, we have to also bring together the data scientists. This is a new kind of engineers that are working in our steel plants and our aluminum plants. And we have to bring those two together because together they are a very powerful mix. And this is a little bit to explain what the title of the too long title of my PowerPoint of today is about. So if you put yourself in the position of this little prince, this is a picture of the little prince, the well-known book by Saint-Exupéry about the little prince that is living on a lonely planet and that is very interested in what is behind the stars, what is happening at the other planets. And this is a lot of our steel producers today are in the same position. There is a huge amount of attention focused on artificial intelligence, and everybody has the same question: what could it bring to me? What will it bring to me? And this is also the what in the beginning of the book of the little prince was asking: what is happening behind all those stars? And this is also a problem that we have to fix. And you will see that we are in a very good position to fix this gap, to fix these amount of questions that our production and quality managers have to solve. And just to as a kind of warranty that you can fix this number of questions and threats that are coming to you, we had it already in the last 30-50 years. AI is not so new. Artificial intelligence is already 70 years old or more. And here you see just a timeline with the first definition of AI by McCarthy and Turing, and then the first really nice experiments of knowledge bases, expert systems, and then of course the big change when Big Blue, Deep Blue in 1997. For the first time, not only we could prove that a chess playing tool could only not nicely play chess, but it could even do better than the human being. Yeah, this is already 30 or 27 years ago. And then, of course, we have the revolution of the internet and the data-driven artificial intelligence that we know today. And there is one missing there. There is, of course, the ChatGPT revolution of last year, which is even putting more questions on the table. But I just want to say, don't be afraid. Let's just be cool and look at the future. It happened very well in the past, and I am sure that it will be very confident to do that in the past. If you look at the same timeline from the steel producer's point of view, well, already in the 90s, there were very, very successful implementations of expert systems, knowledge-based systems in the steel industry, and this started in Japan, in Austria. Also, PSI had its first knowledge base with order addressing. We had the first optimizations of detailed scheduling of casters, etc. And the history went on, and of course these kind of AI applications that today we are using every day around the world, we were afraid about them 50 years ago, but not anymore. So again, I just want to tell you there is nothing to be afraid of. So we had more and more of these optimization and new AI optimizers into the industrial environment very successfully. Why are we so afraid today? Well, this is all because of the way that we are doing AI modeling today, the way we are doing building an AI solution into an industrial environment today with these data-driven technologies of machine learning and neural networks and etc. So they are different in nature. The way that these projects and these models are built, the way they are maintained, the way they are kept, the way they are analyzed is completely different than the traditional expert system. In an expert system, over 3 to 6 months, you collected all the knowledge of the experts, and you put it in a knowledge base, and you were sure that in the end you didn't have a black box. No, you had a very nice, open, clear decision system, and all the rules were clearly defined, not by a black box neural network. No, it was clearly defined and it was clearly documented. This is, of course, now very different with the new world of artificial intelligence. The new world of artificial intelligence is that of machine learning and neural networks, where the big differentiator is that you are not preparing a model with experts and with IT and AI experts. No, you are just looking at data, example data. You're learning from historical production data, and you are extracting a model out of data. And of course, this is the challenge for a lot of production and quality managers. Can we trust this extracted model? Yes, of course, we can try it. We can verify it on test data, but can we really trust it? And this is the gap that is the title of my presentation of today. And this is something we have to solve. So, what is for sure, before we get back to the problem of accepting and trusting prediction models, AI prediction models, it is very clear that the technology behind machine learning is very powerful and has also a huge potential. It can help you making identifications, classifications, predictions, as we already said. So the potential of using the power of machine learning in an industrial environment like steel or aluminum production is huge. Yeah, and here just and the sky is the limit. So there is a huge potential of putting these AI models in all corners of production management. For example, in demand and order data management, you can use historical data to try to be better in lead time prediction or in delivery time prediction. This is not new in forecasting technology, but with machine learning, you can even make it much more adapted to the historical data. You can do supplier classification of your basic materials. You can then, in the world of planning and scheduling, you can verify the quality. Is my production plan not a little bit dangerous? What is the risk that I'm going to fail? So you can predict all that. In the world of equipment, of course, maintenance and equipment maintenance prediction, it's clear that with recording historical information about your equipment, that you can do very nice prediction models based on keeping historical data about the equipment you are using. Quality is probably the most successful domain of applying machine learning, and we will see later with the example of Tfarit how successful that can be, how you can use AI models to predict mechanical properties, or to predict even yes or no, is this going to go to a failure or a quality defect, yes or no. This is a lot of potential there. Also, root cause analysis. If you collect a lot of historical data and then you look at the historical data about your defects, root cause analysis is a very evident result of applying that kind of data analytics that we have with machine learning, etc., etc. So you see, the sky is the limit, and I'm sure if we have today here producers in the audience, I'm sure most of our customers, at least at PSI Metals, are already in most of these areas, already experimenting with putting AI, or at least trying pilots to put that kind of AI models in the daily decision making of what to do and what to do next. So before just some examples, and you will see more examples later by Farid. So in the world of, for example, image recognition, AI is very good in learning from pictures, from digital data about surface images, to learn how to detect images. How to learn how to detect defects, yes or no. What type of defects are we talking about? Just by collecting historical images and defects related to these images, it is very easy to train a convolutional neural network to do at least as good as the human expert, and probably much better. We have multiple cases proven that indeed convolutional neural networks can do at least as good as the best human surface inspectors, and even much better, and of course in a very consistent way. And also the big advantage of a CNN is that it has an infinite way of improving the detection, because the more it is used and the more images it can learn from, the better its recognition will become. Another example of how to use AI modeling is trying to predict the future. Here is one of our pilots that we did with a customer, was that we took all the information about a coil after the production of the coil at the hot strip mill, with all the genealogy that we had and after slab making and hot coil production. And from that moment on, we tried to predict whether, for example, 3 or 4 steps further in the finishing plant, after skin pass, pickling, galvanizing, and painting, whether we would have a probability of creating a defect. If you can do that after the hot mill, of course, you have a huge potential of avoiding that defect, either by changing the parameters of the still to be done steps, or by adapting the coil, or reassigning the coil to another less demanding order, or things like that. So there is, or perhaps changing the route. It could be that you have alternative routes to produce the same finished product, that you have different galvanizing lines, some of them more accurate and more modern than the older ones. Well, this could be a prediction model could help you a lot to minimize the number of defects that you could have after the production of this hot coil. This was a very successful way of introducing AI prediction inside the world of coil production. Of course, the way you have to do that is completely different from a traditional quality management implementation. And you have to collect historical data. You need to train this model in an offline system. And then you have to regularly, because these prediction models have to be retrained from time to time with new elements and new historical data. And then you install the most up-to-date model inside your real-time production and quality environment, where you use this AI model to make predictions about the future. This is a very different way of installing quality models that we know today, which are most of them rule-based quality models. So this is quite different. And again, we will see later, this is also a source of hesitation of especially quality managers to allow this kind of AI models inside their world of production management. Then we have, of course, also, as I already said, in the world of quality, a beautiful instrument for the quality department is to offline use the full genealogy of what happened until a certain defect occurred, and then using all the data from A to Z until the defect was detected, to use all the data, production and process data, to try to do a better root cause analysis than we ever could do in the past. So also here, machine learning is a very powerful root cause analysis tool, whereby this, of course, could then lead to improvements of the production process, or the settings of the equipment. It could be related to different causes, level 2, level 3 causes, why this defect occurred. But machine learning can help there the quality department a lot to use all that interesting data to do root cause analysis and to also avoid these defects in the future. Another potential is not only to predict and to look back with root cause analysis, but also to avoid. So avoiding defects by using what we call process step prescription. You can not only use machine learning to predict what will be the tensile strength after cold mill rolling, and if this is not if this tensile strength or this mechanical property is not inside the range that you need for this customer order, you can change the parameterization of, for example, the annealing temperature or something like or other settings of the production lines in order to avoid that problem, so that you can coil per coil change and adapt the remaining production steps settings, so that you prescribe the production steps to be, and then you will avoid that you will not reach the mechanical property that you need to reach for this customer. This is prescription. This is really coil per coil prescription of, again, you use all your information of historical production steps to find the best parameter settings of your remaining production steps, to prescribe them, so in order to avoid the quality problem. As I said, it is not only in quality and in surface inspection that you can use AI models. The sky is the limit, as we said before. We have also inside PSI Metals very successful implementations of AI models in the world of production planning and production scheduling. For example, it looks like traditional capacity plan-based lead time predictions are not very accurate. It looks like machine learning is much more accurate in predicting lead times than traditional capacity planning. Of course, it could be combined. You can combine, of course, traditional planning techniques and machine learning techniques inside one world of production planning and production scheduling. And this is also what we recommend our customers to do. Now, these are huge opportunities, as I already said, but they are also not so successful. And here, this is just a little bit a negative slide. Although most of steel and metals producers are already experimenting with artificial intelligence, the success rate is not so good. It is even very bad. So 80% of the AI projects, they remain in the pilot phase, and they are not. It's not possible to bring them to a real industrial application of. Although most of them do what initially they wanted to do, so it's not that the technology is not working, but there is a big trust problem, as I said. So there is not enough understanding by the decision makers to put an AI model into a live production environment. This decision has to be made by the quality manager, by the production manager, by the scheduling or planning manager. And if they do not understand how this prediction or this AI model is working, it's very difficult for them to trust it. So, and also sometimes it is a little bit fuzzy. It is a little bit an unclear objective. Then we have what we also in 80% of the AI projects, although we have a lot of data, it looks like in most projects some of the data is mismatched, so there is a lot of cleaning up to be done. So also here, this is not winning the trust of the decision makers to put such a tool in the hands of a human operator to make or to help the operator to make decisions. So, and then of course there is the problem of accuracy. The accuracy of an AI model is always expressed in probabilities. There is a 90% probability that it is okay, but there is an X% probability that I will have a false negative. But okay, what is the cost of a false negative? What is the impact of a true positive on positively? So there is always this very difficult way to work with accuracies of such decision models that AI or machine learning based AI models are. So this is a very trust breaker in the decision making of the human people that has to do. So, and now the positive part. So this is the reality of today that, or at least last year when Gartner published this, that 80% of the AI pilots do not make it really to operational status. And I explained it already so far, but yes, the main reasons is that production managers will not allow to bring a black box into their operations. This is a no-go for a lot of people. And so we have to work on that. We have to make sure that the quality expert and the production manager can understand the implications and the consequences of putting an AI model into operation. So we have to make it a white box. We have to make sure that what we have in front of us is interpretable, that it is transparent. What can be the confidence I can get out of it, and it's not. Managers do not want that it's working in all situations. Also, traditional IT systems are not 100% perfect, but they have to be able to trust it enough, so it has to become a white box. And I push it a little bit further. I would say that what we want to reach, of course, is the trust of the manager that has to make the decision and that has to trust the solution. But I think we should make it even one step further. Machine learning technology is not so fundamentally different from a traditional engineering system. And that was, I come back to my second slide. Don't be afraid. We were afraid of expert systems and we were afraid of optimizers. But once that you can trust them, that you understand what they can bring to you, you will be able to put them into operation. So we have to make that machine learning is becoming a commodity. Yeah, it should be something that should be very easy, a commodity like a spreadsheet that you can put into operation like you are using a spreadsheet on your daily work. Well, also machine learning should become something like that. And this is also not only my hope and my wish, and I think we will get there. And this is also what PSI Metals is pushing for. But this is also where the research, the academic research, is really helping us a lot. So a lot of AI research institutes and also AI companies are really working in bridging that gap. One example of this is Dalex, which is a kind of environment where we help non-data scientists to understand what is the potential of a model and what is the risk and what is the win and the bonus and the malus of using such a system into an industrial environment. So you have to make the machine learning not a black box, but it has to become an explainable system. So you have to be able also, when the system is operational, you need dashboards, you need validation models, so that you can also over time, over the life cycle of putting such an AI model into your operations, you have to measure how good it is, and you can perfectly do that. And concepts like Dalex are really helping non-data scientists to understand how good and bad this AI model is doing in an operational environment. So this is really a very interesting field of research in the AI community, that of explainable AI. And without explainable AI, we will keep that bad situation that most pilots fail. And then, as I said, of course, one step further would be that we can make machine learning into a technology like any other IT technology, that it really will become a commodity, that really it is as simple as putting a database in function, or putting, as I said before, a new spreadsheet into your production loop, or in your business processes. So this is another research topic that is also becoming more and more popular, and it is that of AutoML. So this is, the goal of AutoML is that building an ML model should be as simple as building a spreadsheet. And the full life cycle of data preparation, feature engineering, model selection, model training, hyperparameter optimization, etc. You can read it as good as me. So all these aspects of machine learning, which normally are only understandable fully by the small group of data scientists, and don't misunderstand me, we need those data scientists also in our industrial environment, but we have to, the results of their work and the results should also be fully understandable by non-data scientists. And that is the main idea behind the AutoML organization, which is an academic organization, but which has a lot of followers. Azure is offering it today. Click is offering, Google is offering AutoML, etc. So all the big players already have implementations of this kind of very easy to do machine learning, and deploying these machine learning models into a production environment. This is where we have to go. Is it already available today? Partly it is. And it is as simple as on the little drawing that I made there. Yeah, we just extract historical data from our production environment. We build with AutoML fully or partially automatically, we build a machine learning model, we validate it, and then we deploy this model in our production environment. This should be as simple as this kind of image, and this is where we should try to go. And here, just to show you, as I said, AutoML is an academic open source. There is several open source versions of AutoML. Also, PSI has its own implementation of AutoML, and we are currently already experimenting with some of our customers to put this commodity of building very simple machine learning models into their production management environment with a very simple tool like AutoML. And this is then to complete my presentation. As I said, the title was "We have to bridge the gap." And what is the gap that is really a blocker today in making these AI models into a very performant industrial environment? This is the gap between the data scientist and the production experts. We really have to find a way that these two types of engineers, they are both engineers, and they are both having the same goal, that they understand each other, that we have to bring them together. And as I said before, with Daleks and with AutoML, and there's other potential. Also, Tvarit will talk about already pre-prepared AI models that you just can plug and play into your production environment. So this is where we have to go, and this is what we want to be promoting in the near future. Okay, this was it.
Okay,
This was Robert, who was not here today,
Ah.
and this is myself.
Okay, thank you very much, Luke. Thanks for a great presentation. Couple of questions for you. What are the main reasons why industrial machine learning projects fail? Do they fail?
Well, as one of the main reasons is that although in our IT systems of today we collect a lot of data, but we have level 2 systems, we have level 3 systems, we have level 4 systems, and all of them are islands, kind of islands of data models. And with the details that machine learning very often need is a combination of all of that. And this is sometimes very difficult to bring together the details of a level 2 system, a level 1, level 2 systems with the overview of the level 3 system, and then the even more less detailed world of level 4 systems. So this is some of the problems that you have. You have islands, silos, sorry, is a better word, silos of data models that you have to bring together. On the other side, this is also a unique opportunity to work on that, of course. And then another reason for failure is the main topic of what we discussed today. This is, in the end, this AI model is in the eyes of the production manager. Unfortunately, it is a black box. Very often, it's a black box, and then they are hesitating. And then, of course, also over time, the quality of this black box, if you are not retraining it, is going down very fast. I remember a project where the defect detection after 3 months was already worthless. So you need to retrain very regularly, and this lack of trust is also an obstacle in putting them successfully into a production environment.
Okay, well, look, thank you very much, Luc. Thank you very much for that.